other serious illnesses. Scientists have been working on solutions for years. NASA developed a project called MOXIE, designed to convert carbon dioxide into oxygen by compressing and heating CO2. The system runs on electricity generated by solar panels.
To survive the cold, scientists are designing inflatable habitats and underground bases, possibly built beneath Martian soil or mountains. To shield against radiation, habitats may be covered with Martian soil, or astronauts may wear specially designed heavy protective suits. Some even suggest using Martian caves as natural shelters. For water extraction, NASA and the European Space Agency are developing drilling and heating technologies to melt underground ice. This water could be used for drinking, farming, and oxygen production. Food? Controlled environment agriculture, sealed greenhouses with artificial air, water, and light, has already been tested in Antarctica and aboard the International Space Station. Oxygen, water, radiation, cold, food, solutions exist. But there is one problem that still has no real solution. Mars may look silent and peaceful in photographs, a quiet red desert frozen in time. But sometimes on the horizon, something terrifying appears. A wall, a massive dust storm, and these are no ordinary storms. On Mars, frozen carbon dioxide, dry ice, sublimates directly into gas. This rapid transformation creates powerful winds that ignite massive dust storms. These storms don't just cover cities or continents, they can engulf the entire planet. Global dust storms occur roughly every 3 years. The dust becomes so thick that sunlight cannot reach the surface for months. And this is a serious threat to human technology. Solar panels fail, communication systems shut down, energy production collapses. If humans are to live on Mars, they must survive these storms. But here's the problem. We still don't fully understand them. We may have theories, but even on Earth we can't stop storms. How could we control them on Mars? Mars wasn't always a dry desert. Billions of years ago, it may have had a thick atmosphere and flowing water. But over time, its atmosphere thinned, now only about 1% of Earth's. This thin atmosphere causes extreme temperature differences. During the day, your feet might feel 23 degrees, while your head experiences freezing temperatures. Because the atmosphere is too thin to trap heat, massive temperature differences form. These differences create strong winds. On Earth, storms bring clouds. On Mars, they bring dust. And because gravity is weaker, once dust rises into the air, it can stay there for months. Wind speeds during these storms can reach 160 km/h. But interestingly, the winds themselves are not the main danger. Because the atmosphere is thin, a 100 km/h wind on Mars feels like only 10 km/h on Earth. The real threat is sunlight blockage. If sunlight is blocked for months, solar-powered colonies would lose energy, and without power, life stops. On January 24, 2004, NASA's Opportunity Rover landed on Mars.